Greetings, young mathematicians. Welcome to Saxon Math, Lesson 97, Similar Triangles and Indirect Measures. Starting with the mental math, which you have already done, and we're just checking it. So looking at this one, -5 times -5 times -5, well, we can count our negative signs, and we have an odd number, 3 of them. That means we already know we will end up with a negative sign, and 5 times 5 is 25, 25 times 25, 25 times 5 is 125. So in this case, negative 125. Order of operations, exponents. 5 times 6, that would be 30. And adding these together, because we're multiplying them, would get us 10 to the power of 11. But you know, we can just simplify this one level further by saying 3 times 10 to the power of 12. Convert 5 degrees Celsius to Fahrenheit. So we multiply by 1.8 and then add 32. Then we'll add our decimal. And then 32 plus 9 will get us 41 degrees Fahrenheit. Oops! I skipped over C. Sorry. Okay, so looking at this, we could rearrange this into 3 times m equals 4 5/10 times 6/10. So we can multiply them and then put our decimal in there. So we can see we've got 1, 2 things behind the decimal. So we can go boinky, boinky, would get us 2 7/10. And so we can divide each side by 3, getting us m equals 9/10 for our answer. Okay, now jumping back down to E, calculation. 10 times 6 is 60. And 10 times 1/2, half of 10, is 5, getting us 65. Percent, 25% less than $80. Well, that's 1/4 minus 80. 1/4 of 80 is 20. So that gets us $60. Measurement, 1 cup is what fraction of a pint? That's 1/2. A cup is 1/2 of a pint. Good talk. Calculation. Okay, square root of 100 is 10 times 770 plus 272 divided by 8 is 9 times 4 is 36. Square root of 36 is 6 times 5 is 30. 30 minus 2 is 28. 28 divided by 2 is 14. 14 divided by 2 is 7. And 7 divided by 2 is 3 5/10, or 3 1/2. Which feels like a bit more of an appropriate answer for this one. Okay. Moving to our lesson 97, similar triangles and indirect measures. So we know that when we use these dash symbols, that means that they are the same angle. So we can use that to see that this angle on this triangle is the same as this angle on this triangle. And likewise, we know that these are the same too. So knowing that, that also means we know that the last one has to be the same too, because they all have to add up to 180. So here, I'm gonna add a little 3 one here. So we can say that these two triangles are similar triangles because of the angles and the sides. So looking at that, we can go down here and look at these two guys, where we have two similar triangles, and so therefore, even though they are not the same size, the lengths of their sides will be proportional to each other. So looking right here, we can see that the side that has a length of 10 over here is half as much as 5. And so the same will be true of all of the other side measurements. So 3 is half of 6, 4 is half of 8. It all totally works, which is good because our lesson today is about figuring out what the length of a side is based on similar triangles. So we can look at this and we can say, well, these two are in proportion. So example 1, we are estimating the length of side A. So we can look at these two sides and say, well, if this is a 6 to 10 ratio, then the other side, then these two sides also have to be proportional. So looking at this, we can see that it's a 6 to 10 ratio versus a 3 to, and yeah, so this is nice and proportional because it's half the length, just like our previous example. Therefore, if we really want to take this as far as we can go and include all the steps, then we can make an equation with some cross multiplying fantasticness. So we can say that 6a is equal to 10 times 3, or 6a is equal to 30, and divide each side by 6, getting us a equals 5. But you already knew that because they're just half the length. So now taking this to the next level, to a more practical, scientific level where we're measuring things in reality. All right, so in this scenario, Sarah is wondering how tall the tree is. So Beth looks down. There's Beth. She looks down and says, it's about 25 feet tall. Oh, how'd she know that? Well, she did not directly measure the height of the tree. Instead, she used her knowledge of proportions to indirectly measure the height of the tree. The lengths of the shadows cast by the two objects are proportional to the heights. Because since the sun is in the same position for both of them, that means the shadows will also have to be the same proportion. So we can look at this and say, okay, well, here's the height of the tree. And there is the length of its shadow. And the height of Beth. And the length of her shadow. And so we can look at this as two proportional triangles. And we can set up ratio boxes. So where we have the height of Beth and Beth's shadow and the height of the tree and the tree's shadow, the shadow of the tree. Yeah, not really digging the names that they're HBSB, HT, ST. Okay, anyway. Okay, so if Beth measures her height and she knows she's 5 feet tall and the length of her shadow is 6 feet tall, you're making your own little ratio box here. We'll say 5 and 6. And then we know that the length of the tree shadow is 30. Then that gets us the height of the tree as our only missing piece of information. So, looking at these ratios, well, we can already see that we can kind of cheat and turn this to 1/5. And so multiplying the sides, or cross multiplying, we can get to the height of the tree equals 25, and we are measuring in feet. Okay, so looking at another example here, we can see to indirectly measure the height of a telephone pole on the playground. Some students measured the length of the shadow cast by the pole. The shadow measured 24 feet. Guess it must be close to noon. And then they took a meter stick, and by the way, pretty unscientific to be using two different forms of measurement, isn't it? That's okay. And so taking a yardstick and figuring out the measure of that would get us the meter stick, (100 centimeters). The length of the shadow is 40 centimeters. And the length of the shadow of the pole is 24 centimeters, or 24 feet. Which, once again, don't do that at home, please. Okay, so making our ratio boxes, we essentially end up with cross multiply that, or the height of the pole times 40 equals then 24 feet times 100 centimeters. All right. Oh, and I should have said 40 centimeters over here. Excuse me. Okay, so let's divide each side by 40 centimeters and divide this side by 40 centimeters. Okay, now looking at this now, we can do a little cross-canceling goodness and get rid of the centimeter measurement from the problem, getting us just to one system of measurement with feet. Lovely. And then now we can multiply these to get (240 feet divided by 40 will get us 60 feet. For the height of the pole. All right, so Brad. We'll let this be Brad. Brad saw that his shadow was the length of one big step. Which for him is 3 feet, or 1 yard. He then walked along the shadow of the nearby flagpole. And that for him was 8 big steps, which 3 times 8, so he estimated that as 24 feet. Brad is about 5 feet tall, so what is the best guess for how high the pole is? Okay, well, looking at this, we can say put 3/24 on one side, and we can put just going to say that we can say 5p for the length of the pole. We can immediately break this down to 1/8. Then do a little cross multiplying goodness. And that will end up getting us p equals 40 feet. Getting us our answer. Okay, so now you should do the practice set, and we will check that at 12:45. All right, have a wonderful day. I will see you soon.